Hi, so we're like mapping two-dimensional points to two-dimensional points using neural nets, and we're trying to, I guess, like visualize mappings from R2 to R2 that like a 4-layer neural net can implement that like a 2-layer neural net cannot implement. So like this is layer 1, 2, 3, and 4 of a 4-layer neural net. So like this is the output layer, and then this is the output layer of a 2-layer neural net, and we're using gradient descent to mimic, to get the two-dimensional neural net to mimic the output layer of the 4-dimensional neural net. And I mean, it's kind of like, in this case, it's already like it's not really doing it correctly. But yeah, so then like we can manually play with the weights, but like it turns out it's easier just to like initialize the weights randomly to find. Yes, I mean, this is kind of a good example, I guess. Like it doesn't look like this neural net can mimic like this setup very well. It's not clear if you can characterize that. But anyway, so like we were gonna do like a new app, and the stream like in the similar area there. So so the idea we came up with is we'll have like the large neural net and the small neural net, and actually I can just use this exact user interface actually. So that's cool. But the difference that we're going to do is we're going to alternate like updating the weights of the large neural net and alternate it with updating the weights of the small neural net. And to update the large weight nets, we'll figure out the mapping currently implemented by the small neural net, and we will train the weights and the large neural net to maximize the distance, the Euclidean distance between the large and small neural net. And then for the small neural net, we'll train the weights of the small neural net to minimize the distance. And so yeah, we can use this like visualization. And so like it should be pretty easy to do actually. So this is the code for what the thing I was just looking at. And this is the new alternating training steps. So I should really just have to modify the animation function, and that should be kind of everything we have to do. And then it'll create like a really cool animation. Although I'm trying to figure out how to update the weight display. I think I can just copy paste. Well, yeah, okay, it doesn't matter. Okay, so we just need to update the animation step. So I think we're going to need like a variable up to, because we're alternating, so update small. So that means we're updating the small neural net. if update small, do some stuff, else update large. Okay, so to update the small neural net, we're going to determine the output from the large neural net. And yeah, like we're literally just gonna do this. So I can just copy paste that right over. I also need to update my variable thingy. So on the next one, we don't update the small. Yeah, so that's going to take a step. The problem is that draw layer. Okay, so let's talk about like for the large neural net. So if we're updating the large neural net, it's going to be the same. The problem is I don't know how to easily reverse the, because we don't want to minimize the distance. We want to maximize the distance. And also the output needs to be from the small neural net. So this is the output from the small neural net. And then we're updating the large neural net. And this goes in here. And this redraws, and then we request animation frame. I think that's everything. So the problem though is that we want to maximize the mean squared error. We also need to compile the large neural net because I wasn't compiling it. So I need to do like a custom loss, I guess. Also, yeah, I think I'll go back to like identity function initialization. For everything. Okay, so I'm gonna need to figure out for the large neural net, you know, like we need to take the negative of the mean squared error. So I don't know how to like specify that. So we'll have to like look that up. You wouldn't think it would be that hard, but so if we do compile function string loss or metric function, loss or metric function, yeah, but so mean squared error. Okay, can I like directly pass that? tf dot losses what's it called? Main squared error. Does that work? Let me pass it to the smaller neural net to see if it still updates the animation correctly. Although it's not going to because I already... Okay, well, yeah, but let me go over here and then just replace this and see if it still updates. Because then, like, can I just, like, multiply by -1? I'm not sure you can do that. It doesn't like it. Must be a sensor. Argument labels. Okay, yes, I'm not doing that correctly. Oh, what if you don't call it? Can you just, like, not call it? Okay, and then... Okay, so it still works. So... But I want to multiply by -1. Okay, so can I just say, like, tf dot multiply -1? Is this going to work? No, it doesn't like that. Yeah, I got a function. That's true. Okay, can I just declare a function, like a tf function or something? Like, how do you, can you do like a lambda? Can you pass in a JavaScript function? Okay, I don't see anything that says function. So if we go back to compile, it says it takes a string, an array of strings, a dictionary, loss or metric function. Like, do you just say, do you have to, like, explicitly say the inputs and outputs? No, that doesn't make sense. Oh, God. Is there not an easy way to do this? I gotta say, like, Keras compile custom loss. Would it be the same in the JS? Custom loss. Okay, so can I just make a lambda here? Like, is this cool? Yeah, but like, you have to pass... Oh. Okay, so, yeah, okay, so can I do this? Just say, oops. just say xy, tf multiply mean squared error between x and y. Is this cool? Is this cool, my dudes? Oh man, it looks cool. Oh, it is cool. Okay, alright, well we figured that out. So then I need to, so go back to my thing I'm actually working on, which is here, and then, so this is the large neural net, and it wants to maximize the mean squared error, which is equivalent to minimizing the negative mean squared error, maybe? That seems like it's right. And then the other thing can just do the mean squared error. Okay, so everything should work now, so I'm going to update my HTML file here to call the thing we just did, and it should be the same user interface. Okay. So it's not updating the small neural net. Why not? Grid output, grid, oh, because I didn't, yeah, cool. So this needs to be true, okay. Okay, they're doing it. They're chasing each other. And so they go into a corner. Okay. That's not cool. That's not cool. Yeah. Okay, so what if we do a random initialization? I mean, that was decidedly not cool. So, random initialization. We'll make the weights small-ish. And, right. Let's see what that does. This is not doing what I thought it would do. That kind of changed direction. That was cool. So apparently it just goes into a corner. What if we make the updates smaller for the big one? Okay, go like a little faster maybe. It keeps going in a corner, like stop going in a corner. I guess that's kind of doing something. It might be a good idea to add a weight penalty on the large neural net. Oh wait, what is it doing? It's changed. Whoa. What is it doing? Weird. Right? This is like vaguely cool. Not really, but I think if so let's update the weights so like we know what the, because it's like these are the weights for the large neural net, but like I'm not updating them. But I do have code for doing that. So I just need to do this. So I'll just copy paste that over right quick to my animation thingy. And so when we update the large neural net, we want to redraw the canvases, and then we want to update the weight display. Yes. So it's like do that, and then do that. Okay, so this should update the weight display. It does. Yes, I was wondering if, well, yeah, like just what happens to the weights. Oh, also we're not updating these weights. Let's see, why not? Oh, this needs to be for the large weights. Okay. Okay. I mean, it is kind of doing some stuff. So it's like, what if we update the large neural net twice? Like update the weights twice per time step? Right. Yes, so it seems like it gets stuck. This also might be cooler in 3 dimensions. Well, it definitely wants to get stuck in the corner a lot. Just kind of like, what if the updates... What if... what if we make the big one like 5 epochs per time step? Okay, so like, what if we don't update the small neural net at all? And so like, we just don't update the small neural net. Oh yeah, you have to request animation frame. True. Yeah, okay. But why is it not drawing? Oh, yeah, we also want it to draw itself, though. Okay, so this... Okay, so like... So if you want to maximize like the Euclidean distance to this mapping, it seems like you jam everything in the corner. Although I wonder if that's true of like every mapping. I mean, let's initialize the small neural net like randomly. So I think we'll just oh my god, that's annoying. Okay, so now it's like going to be a random initialization for the small neural net. It kind of seems like in general, like any mapping the large neural net wants to put everything in the corner. Yes. So yeah, okay, so like maybe this wasn't, I thought this was like gonna do some really cool stuff, but it definitely did not. So like the small one goes to the corner. I mean, I think it's like the gradient is like you just keep moving the points that way. But like you can't move the points that way. The only thing I could think of is if you also put a penalty on the magnitude of the weights. Yeah, we'll just try to do that. API. So, like if you can put it on, I don't know how easily it is to, what do they call it? Regularizer? Regularizer. Ooh. So, do I just directly pass that into the loss? Try that. So tf.regularizers.l1. Or is it like, is there a special thing for it? Optimizer, loss, metrics. Okay, so I think you just, we like add it on the loss. I'm not really clear how you would do this. tf.regularizers.l1. Yeah, okay, so let me look up the Keras regularizer. Kernel regulate. Oh, okay, so there should be a keyword. So it should be like kernel regularizer. Yeah. And then, do you also need one for bias? Yeah. Okay. And why doesn't it like... Oh. Okay. Oh my god, what's happening? Jeez. Okay. So we'll put regularizers on the weights for the large neural net, and it will break. Expect it to be an object. Yeah. What if I just do L1? I don't really know what the difference is. And... but that needs to say L1, I think. Okay. Okay, so let's make it like a stronger term, maybe. Well, the weights are definitely smaller. I mean, so basically it just wants to push all the weights into a single point. And then when the small neural net gets closer, like maybe it will move the weights. Or it'll move the grid. Yeah, like it'll kind of move the grid. Okay. Well, at least it doesn't get stuck in a corner anymore, right? Like it'll... okay, so let's make the small neural net like quicker. So we'll like double its epochs. Okay, so it moves the grid around. I think like we definitely got oscillatory behavior, right? Like it's just gonna move from one corner to another corner. so kind of gave up. I mean, I guess there's like some sweet spot in the hyperparameters where it will maybe do interesting stuff, but yeah, okay, so it turns out that wasn't really all that interesting. So there you go.